Good morning, everyone. My name is Nick Wyllie. I am the environmental planner for the city of Attleboro. Welcome to today's second public meeting for Attleboro's downtown flood mitigation and resilience project. So as a recap, this project started well over a year ago, working with our project partners from Horsley Witten Group. And this project is being funded by a Building Resilient Infrastructure and Communities grant from FEMA. In addition to that, also funded by a 25% gas match from the city. So the purpose of this project is to explore options to reduce flooding in the downtown area. During today's meeting, we're going to present a few different potential actions that are recommendations from our engineering partners at Horsley Witten Group of how we can increase our resiliency to flooding and increase flood capacity within the downtown. Some things to note, though, is that any of the actions that you see here today are not anything that the city has committed to at this time for implementation. A lot of these actions will require further design plans and evaluation, as well as public input. I want to make sure that's abundantly clear that we are seeking public input on these actions, so that will adjust our design plans as we move forward. Something else to note is that the actions you see today, we have not presented them yet to the mayor or the city council. That will be done at a later time. So you are some of the first members of the public to see some of these potential actions. But following today's meeting and culminating with the end of the project, there will be a full report that will be available for public review. So moving forward, I'm going to kick it over to our project manager at Horsley Witten Group, Michelle West, and she will get us started.
Thank you, Nick. It's good to see all of you here on a beautiful Saturday. I know it's a busy time of the year to get people inside to talk about flooding. I just wanted to introduce myself. I am a senior water resources engineer, and with us today we have a team from Horsley Witten Group. We have Jonas Procton here, who's also an engineer. We have Ariel Schramko, who helped a lot with the modeling that you'll see presented here, and Johanna Walzak and Krista Moravec, who are part of our planning team that helped pull together some of the boards and the materials and helped us advertise for this meeting. So thanks to the whole team. All right, so just an agenda of what we hope to cover in our presentation, but I just want to say we're definitely sticking around afterwards. If you have questions that you didn't get the answer to during the presentation, we're going to be here. We've got informational boards in the back. Definitely want to discuss any questions or concerns that you all have. But just to start with the project overview, Nick covered this for the most part. But just to reiterate our project goals, we wanted to understand the existing conditions of the river. Why we're seeing the flooding in places that we are, what are the potential causes of that, where are the key points along the river in this area to really focus on. And then identify and prioritize strategies that can reduce flood risk into the future and increase that resiliency. So kind of to start it all off, we need to start with understanding what a floodplain is. The natural river process involves the river channel, which you can see on the left there in blue, of course, and something called a floodplain, kind of on either side of that. So what happens is that during normal base flow conditions, dry, sunny days, you have a river, there's water flowing through it, and it stays within its channel. And then as it starts to rain, if we have smaller rain events and the whole drainage area, the watershed is contributing flow into the river, the water starts to rise. Up to a certain point, it's still going to stay in that channel. But when we get those really big events in natural conditions, the water floods over into a vegetated floodplain. The trees and the plants that are growing there help to slow the water, absorb some of the sediment that might be in the water, and it's just part of this natural system. Well, what happens is that, of course, people need to live somewhere, and we need to have our work and our businesses and whatnot, and over time, humans move into that floodplain because, again, during normal sunny days, it's dry. It seems like a great place. It's fertile soils, all of that. And water was really useful as we were building our industries. So mills, all the industries that help make Attleboro what it is today, used the river. And so, of course, it was the easiest to place our buildings and our businesses right on that river. For the most part, it was great because of the dry, sunny conditions, or even if it rained a little bit. But by building in that floodplain, that made those businesses and homes susceptible to flooding. So humans, being humans, we like to try to control things, particularly nature. We tried to build things up. We're like, we're going to stop the floodwaters. And so then you might see walls along the river channel, trying to block the flows, or in other cases, slow the flows. And over time, we end up with a very impacted, urbanized river system, and that can lead to disastrous floods in the floodplains, as we've seen on the news and a variety of places. Unfortunately, it's getting worse and worse as the climate is changing and our storms are coming more intense and more frequently. So that's kind of the background on what we're talking about today when we think about floodplains and flood zones. This is a graphic that likely many of you have seen before. It's really focused on the study area for this project. We are looking at the impacts to downtown Attleboro in particular. And so we wanted to make sure we had a wide enough study area to understand what was happening in the downtown. So we expand up past I-95 there, and our model looks all the way down to Dodgeville Dam as part of this study to really kind of hone in on the things that are impacting the downtown. Also on this figure, it's a little hard to see, but we included the FEMA mapped flood zones. So they go through a variety of modeling and studying to try to understand where that flood zone is. And they focus on what a lot of us refer to as the 100-year flood event. But a better way to think about it is the 1% probability or chance that you'll get that event every year. So, because people think, well, it's a 100-year event, we should only get one in 100 years. But really, you have a 1% chance of getting it every year. And as we've been seeing, that is happening more and more frequently. So we're going to try to refer to it as the 1% chance event to just try to help kind of drive that home. But it's the same thing as what other people would call the 100-year flood event. So we're really focused on looking at impacts at the County Street Bridge. We know from talking to all of you and looking at our model results, this is a critical point for the city. It's a very important arterial road, and that is where we've experienced a lot of the flooding in recent years. And so that has really been where we've focused our efforts. So the project overview for this particular study involved 8 different tasks. And at the last meeting, we were really kind of focused back on tasks 3 and 4. And since then, so that was in May, we have done a lot of technical modeling work and looking at what strategies and measures might help reduce those impacts. So I've highlighted 5 and 6 there. And then the next steps after this meeting is we go into a benefit cost analysis. That's not just a general benefit cost analysis. This is something specific that FEMA requires as a part of this grant. And then we develop the flood mitigation and resilience plan that can be guidelines to help the city moving forward. It's, nothing is, as Nick pointed out, nothing's going to be built tomorrow. This is just looking at the opportunities and the strategies that are available to the city. So what does a model like this look like? It's not pretty. We use something called HECRAS. It is pretty much the status quo for how you would model floodplain systems and river systems to look at impacts. It's an Army Corps-based model, but it's been improved over the years, and that is kind of the industry standard. And it's really looking at how that river functions and trying to mimic. Models only try to be able to mimic what nature would do, but there's a lot of pieces to this particular model that help us put a lot of stock into its results. What you're seeing there is the river channel, kind of here, through the city, and then all these crazy lines that look like some sort of creature, those are transects. So that is just how the model knows the shape of the land. So if you drew a line, a magic line through down County Street by the river and across, this would show the elevation at each kind of point along that line. So we need lots of those transects to understand the shape of the land and how water would flow if it leaves the banks of the river throughout the downtown area. Some of these were existing that FEMA had in their model. Some of them we went out and surveyed ourselves. We used a lot of different sources for this. We're looking at rainfall amounts and river flows. There are river gauges at different points in the 10-mile river that the USGS is measuring flows. We're looking at that. We're looking at the water department's data on flows. And then we're also looking at constrictions and impoundments. Having a good understanding of where the pinch points are in the river and where things are backing the water up or impounding it, which could create a whole pond, or in some cases you wouldn't even know it's being impounded behind a structure. And then this here doesn't look like much probably, but what that is representing is the profile of the river. So if you were in the middle of the river and you walked all the way down, this is what it would look like, and this is mimicking the water elevation of the river. So the bottom of the river here, and these are all different structures along the way, different bridges and whatnot, and that's kind of how, another way that we look at the river from this model is the profile. This is looking down on the model, and this is looking kind of across the river itself. All right, so the existing conditions model, it's really important that we have a good understanding and a representative understanding of how the river is acting today. So as I said before, we modeled, it's about 3 miles or so of the river from I-95 down to Dodgeville Dam. We used data from previous studies. I mentioned FEMA already, but there were also 2 studies done on Farmers Pond Dam and Mechanics Pond Dam that also modeled and had a HECRAS model for those systems, so we were able to draw from those. And then past city projects, we also used a model similar to this, but much smaller scale for Riverfront Park and Riverwalk Connector projects. And then we looked at those recent flood events that I'm sure many of you remember very well, the October 15th, 2005, March 30th, 2010, and September 11th, 2023 events. How much flow, how much water, how much did it rain, and looking at the USGS gauge information for how deep the water was during those events to help calibrate our model. And we also thought about the North Attleboro issues. We know that they're obviously upstream from this area, and there are dams up there, and they do sometimes release flows from it. And so we're able to think, like, when they release flows, how does it compare to the event that we're using for this study? And those releases would be less than what we focused on as our flows. We're looking at that 1% probability event, so the really big events that those storms kind of represented, or the 100-year floods. So the project study point is County Street. I already touched on this a little bit, but just wanted to bring that home, that is a critical arterial road for the city, and of course the businesses around it, but also people trying to get from place to place, emergency vehicles during emergency flood event. We want to be able to keep this open if possible. But there are many other vulnerable structures and roads along the river that are incorporated into the model But what we're looking for are the most impactful strategies for this particular point. That doesn't mean that some of the other constrictions that we'll present wouldn't be important for localized flooding, but really this study is focused on that point. All right, so just to go through some of the existing constrictions or bridges that we have in the study area. You can see, I'm sure you're familiar with all of these areas, but Water Street Bridge at the upstream end. This pedestrian bridge, just to clarify, is the Sterling Lofts area. There's a pedestrian bridge there that is not for vehicles to drive across, but that's what that constriction is. There's the Mechanic Street Bridge, County Street Bridge, Wall Street Bridge. There's Hodges is in here as well. We've got Olive Street, and then a railroad bridge at kind of the downstream, one of the downstream edges of what we looked at. So these bridges are undersized and constrict flow in the river, causing quote-unquote backups in the area upstream, which can lead to flooding depending on how much of a backup. And the location, size, shape of these bridges are included in the model. And we'll get into a little bit more on this, and I think we have boards up as well for each of these. And then there's the existing floodplain, just as a reminder, kind of talked about that earlier. We know what a natural floodplain wants to look like, and the existing floodplain has been changed over more than 100 years. The channel has been separated from its floodplain. We've got walls along the river. We've got buildings. We've got roads. Those structures and the kind of shape of that area is included in the model. We also have existing impoundments caused by dams. So I list the three here. We've got Simmons Pond Dam, Farmers Pond Dam, and then Mechanics Pond actually has two structures, a dam and a dike. And just to give you a sense of the purposes of these dams originally, Simmons Pond Dam, as far as we know, was created for recreational purposes. We don't have any documentation that it was for an industry or anything like that. Farmers Pond Dam originally was created for ice harvesting, and now is mostly recreational for those that live around it. And then Mechanics Pond was definitely created to help support a textile mill in that area, actually where Sterling Lofts is today. So those were the original purposes for the dams. The Office of Dam Safety determines a hazard class for dams, and all of these are considered significant hazard dams, which means that they, if something happened to them, that they could cause significant damage and threat to safety downstream. The condition is determined by various inspections that have to be done on the dams, and our best account of recent condition is that most of these are in poor condition, and Farmers Pond recently was determined to be unsafe or unsatisfactory condition. The max volume that's being held back by these dams, this is given in acre feet, which isn't maybe the most helpful volume, but you can see that Simmons Pond has a really pretty small impoundment behind it. Farmers Pond is a little bit different, a little bit bigger, more than twice the size of Simmons, and then Mechanics is quite large at almost 100 acre feet of storage water being held behind the dam. All right, a little bit more on each one. Simmons Pond was originally Blackington Pond and was privately owned. It is now city-owned. It was built somewhere in the 1920s. I couldn't find an exact date for that, but it was in that time frame. The dam spillway is pretty small. It's only 8 feet wide, and the dam height is holding back water about 6 feet high. And it's actually impacted by the downstream Mechanics Pond. So when the Mechanics Pond is holding back a lot of water, it comes up and is impacting the effect of Simmons Pond Dam. it's adjacent to a public park. So people do go and can sit, and I think there's picnic tables and benches and that sort of thing at the dam. Farmers Pond Dam, built in 1892. It has a 44-foot spillway, and then it has a second spillway that's about 8 feet. Its dam height is 10 feet high. It has needed some emergency repairs in recent years. 2019, it's had some problems where it was threatening to fail, and they went in and did some emergency repairs there. There's no public access other than for immediate abutters as far as I could tell. And then Mechanics Pond. This was originally dammed in the 1800s. The spillway is 41 feet, and then the separate dike is an earthen berm or dike that is 300 feet wide. It has a dam height of 11 feet. It does have a low flow outlet controlled by a valve, but as far as we know, it is not operable at this time, and it is adjacent to public trails. And then one more thing on kind of the existing conditions of the river system is the sediment. There is some sediment buildup in different places. Sediment buildup is also called sedimentation, and that can impact habitat in the channel, and also it can reduce channel volumes. Sedimentation is impacted by sediment sources. So where is all this coming from? Is it coming from the channel itself, or is there some man-made impact that's sending sediment into the river? The sediment size, so if you think the difference between a piece of gravel, which is considered sediment, and really fine material like a silt or a clay, and how that moves through a river system makes a difference in the type of sediment buildup that you see. River velocity is really important. Where you have a fast-moving river stretch, you're not going to have a lot of sediment buildup. And river velocity is impacted by impoundments or constrictions, so they go kind of hand in hand to where we see sediment buildup. So with that, I'm going to hand it to Jonas to talk a little bit about what strategies we evaluated.
Thanks, Michelle. So as part of this project, we were looking to identify all the different possible points along the river that might be causing flooding, causing impoundments, causing the water to build up, and then identifying different individual solutions that we could, bring forward and develop as a scenario to reduce flooding along the river, and also see how they worked together, how they interacted with each other to potentially bring about the most reduction in flooding with the best combination of scenarios along the river. So that included dredging along the river, removal of sediment by machines, removing constrictions, so that could be widening bridges, adjusting infrastructure, so widening or raising bridges, as well as removing dams potentially, and any sort of scenario that might provide more flood storage. So in some cases, widening the banks, especially where maybe a wall has been installed along the river, which is actually blocking the river's access to the floodplain. Is there an opportunity to allow the river to access that floodplain easier, potentially lower the wall, get into the floodplain? So I'll talk a little bit more about each of those. And here is a map, and we also have this as a board in the back that we can look more at later if anyone's curious about any of these individual scenarios. But we looked at over 10 different scenarios that could help restore the natural river functions and also improve flooding along the river, reduce flooding. And so we were looking at each of these scenarios one by one, and then we tried to combine different scenarios to see which could get the most benefit. Make sure. So Looking a little bit closer at dredging, like I said, that is the actual removal of sediment from the river channel. We look at places where sediment has built up in the river channel. So looking a little bit more at dredging, in terms of short-term benefits, you're freeing up this flood storage space in the river, removing sediment that is taking up volume that the river has to fill up when a heavy rain occurs and the river floods. But it's important to note some drawbacks of dredging too. So that includes the expense. It's very costly to physically get into the river and remove the sediment. It can also damage the habitat. Think of all of the creatures in the river that live along the bottom. And because of that, it can be really difficult to permit. It can be difficult for the state to approve of a dredging project. And there's less readily available funding that could be applied for to get a dredging project. It would take potentially more funding from the city and less from the state or from federal grants. And dredging doesn't ultimately fix the root cause of what is causing sediment to build up. So like Michelle said, things like impoundments in the river, constrictions that slow down river velocity and cause sediment to build up will ultimately continue to cause sediment to build up as it hits these slow velocity zones, and there's not enough flow or velocity in the river to keep sediment moving along. And so if the root cause of the sedimentation isn't addressed, dredging would be needed another time or on an ongoing basis in order to make sure that the benefit you get from freeing up that capacity in the river is still available. And specifically how we look at it in our modeling, you can see this figure on the bottom. So this is the profile that Michelle was talking about. And here's just to zoom in between Olive Street Bridge and Wall Street Bridge. And so from the existing surveys by FEMA and from our own surveys, we find locations where we actually see the channel bottom has these mounds of sediment. And we sort of draw an imaginary line tracing the slope of the bottom of the river for what we think the slope would be, and we can see where sediment has built up. And those are locations that we identify as the likely scenarios where dredging would occur.
Jonas, can I ask a quick question? If
Yes.
you go back to that.
Yeah, absolutely.
In that situation where you have that imaginary line that would say a constant slope, I see where there's areas where you could slow water down, creates volume, void volume capacity where it stands out, so you would dredge those areas. That right? So this might be a silly question, but I want to ask: where there is water capacity below the line, would that be filled to create a smooth bottom, or would that remain?
Yeah, that's a good question. Those would probably be allowed to remain, so those would be probably natural lower points that would occur maybe as a result of structures in the river or sometimes just deeper pockets in a river, especially if a river bends, it tends to just get deeper in that one area. So you wouldn't be filling in areas, you would just be removing sediment.
Thank you.
Yeah. So next up, we'll look a little closer at the bridge adjustment scenarios. So we looked starting from the downstream end of the river, working upstream. And the reason for this is typically you get the most benefit upstream from a downstream project. If you free up a pinch point downstream, everything upstream of that, in theory, will have a greater ability to flow through it. And so we looked at each of these bridges individually. We identified certain bridges that had the most benefit, and we also found ones that worked considerably better when paired together. So starting with the railroad bridge, that's the downstream end of our project area. So the existing bridge, it's this 26-foot wide stone arch bridge. And the bankful width, or the natural width that we estimate the river to be in this area, that's sort of the width that you would think if humans had never touched the river in the first place, this river would be this wide when it's not flowing over into the floodplains. We think that natural width would be 45 feet. So this bridge is almost 20 feet narrower than we think it would naturally be without human activity. So we modeled it having access to a 45-foot wide rectangular bridge. And you can see this is in the model, basically what that looks like, widening it from 26 feet wide to this sort of blocky 45-foot wide opening, and so freeing up that space for flow. And as a result of freeing up that space, the model also tells us that velocity in the river would pick up because flow is now able to go through it, and that impoundment is reduced. And so we also model sediment transport occurring. So the same results essentially that you see from dredging are also simulated and would be expected when you restore the natural functions of the river. By restoring the river's natural processes, it keeps sediment moving like a natural river system continues to carry sediment along. So the next upstream bridge we looked at that we found considerable benefit was the Olive Street Bridge. That's immediately upstream. So again, a natural estimate of the river width would be 45 feet in this location. The existing bridge is about 10 feet too small. And one result I want to point out with this is that Olive Street and the Railroad Bridge are so close to each other that they actually sort of interact. They impound water together. And so increasing the size of one without the other, the impoundment just starts to fill up into the other bridge, or you're releasing the impoundment into the other bridge. So we found that these bridges work together in a way that you get the most benefit by widening both of them as part of a larger project. And the last bridge that we identified as having a really significant benefit for not only the downtown area, but our specific study point of County Street, keeping in mind that's where we were focusing our results for comparison's sake. So the County Street Bridge itself is, again, about 20 feet, more than 20 feet narrower than the natural system would be. And then upstream of County Street, retaining walls that keep the river in a channel continue to pinch the river. And so floodplain restoration upstream of the County Street Bridge was also included in our scenario that we were exploring. And so to give a better look of that, this was the general area that we were including in our County Street restoration scenario. And so unfortunately, Riverbank Road is on the low side upstream of County Street, whereas the Balfour Riverwalk is a bit higher. So the first place that when a flood occurs and County Street is backing up, the first place that water flows to is the Riverbank roadside, where there's already buildings and the roadway. And so we looked in our scenario at lowering the wall on the Balfour Riverwalk side, making a floodable park, a park that most of the time it's totally above water. People are able to play in it, and then in the rare flood event, maybe once a year, once every 2 years, water is able to flow into the park, doesn't damage the park would be built in a way that, it stays in place and it's stable, but it creates this new flood storage capacity. It's almost like a release valve before water can even get to the Riverbank Road area. And so this created another large benefit for the County Street artery specifically.
Got a question for you. You're
Yes.
going to make that a floodable park. Are you going to lower the park then? Because that park is right now 2.5 feet above the water line, or even above Riverbank Road. So you're suggesting lowering the park?
Right, so to make it floodable, the park would lower, it would still be above what we would think would be typical, even like high sort of water levels in a typical range, but it would be low enough that it could flood, but the park wouldn't be damaged as a result of that flooding. So you'd have stable structures, stable, benches, play equipment, any sort of, features in the park that wouldn't be damaged as a result of the flooding.
Gotcha, so you're planning on feeding it out?
Right, it would involve excavation, yeah, digging lower.
When we talk about lowering, we're not talking about necessarily dropping the whole thing down, but it would slope down. So you've got that river wall, where as you walk by on Riverbank Road, and you've got that ornamental wrought iron fence where you can look down. So it's not a matter of just dropping the whole thing X amount of feet, where now you're creating a massive wall on the right side where North Green Street is. It would be kind of like just sloping it down so that the water could rise up.
Still have to drop the whole thing down
Well, no,
because the
that's
whole thing is from start to finish, from the river all the way to the mechanic shop. It's still 2 feet higher than the water all the way through, so.
Yeah, I'm just thinking, what the skateboard park is?
Yeah.
Okay, so if you're using that as a reference, what I'm saying is right now, we haven't designed it, but it's not like from that point all the way to where the river is, from the skateboard park, is necessarily excavating and dropping it down. If that kept the elevation where the skateboard park is, right now it goes straight across and it just drops off. It would come out and where that kidney-shaped concrete is, from there it would start to slope down. So yeah, there's gonna be some excavation, but I just wanna, it's not like the whole thing would be dropped.
Yeah, I think if I can add to what Gary's saying, like you could excavate and have terraces that are maybe lower and recreate a floodplain, and then it would ramp up to higher portions of the park. And I do want to emphasize, no design has really occurred yet. We look at it just as a scenario that would need much more development. Question back?
Yeah, so with the intended slope, is that with the current volume of water that we're predicting now? Or is it the volume of water, the bridge is expanded, the dam's removed, and more velocity, including more volume by cubic meter? Which scenario are you operating with? Just so it's like, oh, we do 2 feet slope now, we introduce 5, 6 square cubic feet of water, now we have to have a 3-foot slope.
Right, yeah. We first explored just widening the bridge and doing those downstream bridge scenarios too, because I think to your question, the lower impact, lower level of intervention and less invasive work that needs to be done, the better, the cheaper, the less you have to change your downtown area. And we didn't find enough of a benefit to achieve, preventing flooding at County Street Bridge without also introducing more of the floodplain into that park area. So that's why we kept advancing the scenario into some floodplain restoration. Anything else before I keep moving?
I have a question for you.
Please.
On the Riverbank Road Bridge,
Right.
you want to widen that. There are houses along Hayward Street who back up to that. What would happen to those? They flood down, the backyards flood now.
You're saying in the County Street side or on the upper side?
On Riverbank Road,
On
where it
Riverbank.
hits Hayward Street. It's Hodges,
Is that-
Hayward.
Okay, yeah, right there.
All right. There are houses on the Hayward Street side
Yes.
that flood now. They're in the floodplain. I own a house that's further up, and I'm not on the floodplain, but my house in 2010 did flood.
Mm-hmm.
I watched the grates going up and down on the street with the water.
Right.
What is that widening back going to do to those backyards now? Is it they going to get more?
Well, the hope by creating more flood storage downstream is that lowers the water elevation in this whole area, so it creates flood storage. So rather than rising up because of these narrow channels, it can expand out, and so that would lower the water levels, and especially upstream of this point, it would lower water levels, and hopefully prevent that flooding. Yeah. Okay, I'll keep moving along.
I got one other side question.
Yeah,
actually.
please.
So you talked about the bridges, opening up the bridges, kind of like a funneling effect. You want to funnel more water through and everything else. The waterway here, unfortunately, is very restricted, especially all the way past, one tower going towards that final bridge you pointed out on the lower right. Is there also a chance that you're now going to funnel so much water through, regardless of the velocity, that it's going to overload because the channel is just way too small as is?
Mm-hmm. Yeah, it's a very good question. So the hope with a lot of these restoration scenarios is that by opening up the bridges, it's not going to cause more water to flow through. It's freeing up just a pinch that is raising water levels. So at a certain point, often the bridges, they raise water levels high enough that, and it gets a little bit sort of like sciencey in this, but the weight of the water starts pushing it enough through that it increases the flow under the bridge and it reaches the same flow that it needs to achieve anyway. So another way of thinking of it is that the flow coming into the river is the same that leaves the river all the time. Flow in equals flow out. You're not, getting more flow, just increases going downstream. It's the same, like when you're running a sink, it's the same flow going down constantly. And so by opening up that pinch point, you're not increasing the flow that's coming downstream, so you're not increasing water levels downstream. And we make sure that's the case in the model. We would never suggest a scenario that will increase water levels, flooding anywhere. But we free up this pinch point that's causing it to build up in order to have the pressure to flow at that same rate.
What we could see though in that channel is potentially higher velocities with doing the railroad bridge and the Olive Street Bridge. So I think just keeping that in mind, making sure we check if there needs to be any additional kind of armoring in that section between county and wall, I think is what you're asking about, like what the input packs could be in that channel. Because it's true, that is a tight channel with walls on either side, and one day if we have a chance to be able to widen that as well, that would be beneficial, but we're trying to focus on the most impactful for this study in the near term.
Does that help before we go to another question? Does that kind of
Helps a little bit. Again, it seems like it's more of an issue than, well, again, I understand why increasing the flow of bridges makes sense, but it seems like it pushes the problem downstream really overall, and no matter what, you're still gonna have that massive flow. So again, love to see the rest of it.
this next question?
My apologies for getting here late. So
Yeah,
if
no
this
worries.
is not related to exactly what you're talking about, by all means, you can answer another time. But it might be a question more for Nick and Gary. But what are we doing to involve, say, North Attleboro? Because a lot of times that's where a lot of this starts. And so I don't know if it's already been asked, and I apologize, but because obviously controlling what North Attleboro does is going to lay a big part of what happens down this way too as well.
Sure. Yeah, so I mean, we do have a notification process with them for when they do a dam release. First they start by notifying our Department of Public Works Superintendent Mike Tyler. The mayor is also on the notification list. Fire chief, yep. So we do have that process in place. There are written procedures for that. And then we can take the existing land area of Falls Pond where they're releasing that water, get the estimated volume that they would be releasing if they're saying, okay, we're gonna pull out one board, drop the water levels by 1 foot, 2 feet, get that estimated volume so we can try and account for that in some of the flood scenarios that we have here.
Are we confident now that we won't have a mix-up where someone was just standing in part-time and just went and did his own thing and, we flood out,
Yeah, so we've discussed, I don't know if this is the correct term, but like a continuity of employer procedure, where if someone does move on, they have these written procedures. So for the next person that comes in, they go, okay, I need to do X, Y, and Z in this scenario. And then it's really on the administrations of both municipalities to make sure that the contact information is staying up to date as people start to change over jobs and careers.
All right, cool, thank you.
But then as we, start to, evaluate further actions, of course, we're going to be looking at North Attleboro to see, okay, what do you guys have for evaluations that you're, actions that you're evaluating currently? We're aware that they are doing a dredging project at the 10 Mile River with some federal appropriated money. So as that progresses, I don't know exactly what stage they're in currently, but I do have my counterpart I have a good relationship with over there. So I am reaching out to them just to see if there's any potential collaboration that we can do. There is a lot of private property, though, in between, I would say, upstream of Farmers Pond and North Attleboro's Falls Pond. So I know there's a lot of channelized sections there. So there'll be a lot of public outreach that we really need to do to see if there's any regional and collaborative opportunities that we have. But it's absolutely on the forefront of our mind to make sure that we are collaborating.
Great, thanks, appreciate you being on top of that.
So there was talk about North Attleboro upstream and here, but what about downstream? Because I live downstream from this, so if you dredge this and it picks up velocity, isn't that gonna be worse for us?
So part of these projects is more about creating flood storage. So creating by freeing up these storage spaces or lowering water levels, reducing impoundments. All of that area that was filled up with water is now able to fill up with water. So we wouldn't be sending more flow downstream. We wouldn't be sending more velocity downstream. We would be essentially freeing up space for the floodplain to act as a floodplain and fill up and be this natural storage that the river can use rather than having it confined. And so the goal would be not send the problem downstream, but take care of it along the study area.
And you did
So
look,
just to say, there's a velocity and volume aren't the same, so the velocity, right, is the speed of the water versus the volume of water. So when it rains, it's the same amount of rain that's gonna come, right? So by widening these, doesn't mean more rain is gonna come. The question is, through these designs, how do we best manage that volume of water that's coming down? So Diane, just to answer your question, so could there be an increase in velocity? Of course, we're gonna look at that, because with velocity, right, there are erosion can occur as that by scouring or taking down. So what we're looking to do is create volume capacity so that the floodplain doesn't expand any further, and so that the river goes back to the extent we can to what it would naturally accommodate for water volume. If there is an increase in velocity, which we're going to be able to look at, that would still be constrained within the river channel, not widening it down. So I just want to make a distinction between velocity and volume. What we're looking to do is contain that volume.
and we did look at points downstream of the railroad bridge during these scenarios to specifically look for impacts all the way down to the dam, and there were not increases that we could see with the model. And also, nicely, downstream of the railroad bridge, we have more wetland area, more space, more, I don't know that it's natural floodplain, but closer to natural.
I live much further downstream than that.
Okay.
Live
Okay.
Yeah.
Yeah, we're,
Oh, okay.
Yeah.
So the Dodgeville Dam is in between, probably where you are from this project, right?
But, I live near Sweden Swamp,
Yes.
near Pawtucket.
Okay. So the impact of this, if we looked at these strategies, I would say it would not be an impact for you down that far.
Overall, sounds like a pretty good plan. My only question is regarding potential soil contaminants. So as the velocity picks up the sediments from the bottom, so going back 50, 100 years, what lies underneath that muck? Right? How or what potential remediation plans or preventative plans are in place to prevent that from spreading?
Yeah, it's a good question. It's a really important question. Stick around as we talk about dams for sure. But the short answer is that none of these projects would occur without coordination and approval through state permitting. So the Department of Environmental Protection, DEP, any project where you'd expect any sort of sediment transport to occur, like these projects, you would need to sample the sediment, identify contaminants, essentially characterize what's in the area where you expect transport to happen, and identify what is the makeup of the sediment downstream of that, the receiving areas. Attleboro and the 10 Mile River, there's this history of industry and contaminated sediment, and in a lot of cases, releasing sediment from one area, it might be going to a more contaminated area downstream. It might be settling there, and in some cases that could actually improve what we call the quality or the contamination level of the sediment that it becomes the top layer. So it's not without precedent that allowing more sediment transport to happen, that, even if it is past some contaminant thresholds, if it's going to a more contaminated area, there's plenty of precedent in the state for allowing that sort of project to happen. But either way, there would be a lot of coordination, there would be a lot of, permitting and overview from the state.
I just, I had a comment from my friends on Sweet Swamp to just kind of reassure them. The way this actually works is the water from the 10 Mile River does not flow into Sweet Swamp. The water from Sweet Swamp flows into the 10 Mile River through the 7 Mile River. So this particular project right here will have no impact on Sweet Swamp, actually. So this water is actually not heading there. So although there's flooding issues on Sweet Swamp, this actually will have no impact on that.
Thanks for adding that. Okay, anything else before we keep moving? Okay, so as promised, dams. So we looked at 3 different dams near the downtown area that Michelle ran through earlier. And just a quick zoom out, Massachusetts has over 3,000 dams in the entire state, and there are only about 350 towns or cities in Massachusetts, so that's pretty remarkable, I think, more than like almost 10 dams per town. Many of them are in poor or unsafe condition, and all 3 of the ones we looked at in the study were poor, or this is the worst condition that can be rated by the Office of Dam Safety, unsafe in the case of Farmers Pond Dam. So these dams in the project area, there is no question that something needs to be done in terms of addressing their safety. Farmers Pond, already had this emergency repair done in 2019, and all dams, especially the higher hazard, the dam, have ongoing costs, not only repair, but inspections every couple of years. So that's an ongoing expense for the city. And so something has to happen with the dams eventually. And dam failure, if it occurred, would cause not just your typical level of 100-year or the 1% flood coming downstream, but the entire impoundment, those vast acre footages that Michelle ran through earlier, all rushing downstream at once. And all of these dams being rated as a significant hazard dam could involve potential loss of life. So dam removal was a scenario we looked at not only for potential benefits to everyday flooding, but also preventing a disastrous flood that could potentially come downstream. Dams themselves cause water quality issues. They trap contaminated sediments or trap sediments in general. They are, they heat up water. They kind of slow down the water, and it becomes almost like a parking lot, just absorbs the heat of the sun, so that reduces the water quality in the river, impedes any sort of fish passage up the river. So they worsen water quality on their own. And there is plentiful funding from the state for dam removal, much, much more so than a dredging project or than rebuilding a dam project. There's a lot of funding available for removal, and there are only a few grants that go out every year for rebuilding a dam. Dam removals occur very slowly. It's not like the failure scenario. It's a very intentional, slow removal of a few inches or a foot at a time of a dam to prevent some sort of rush of water downstream. And there have been, since 2005, about 40 dam removals that have occurred in the state, and all across the state, the rate of dam removal is accelerating. This sort of restoration strategy is picking up speed. It's gaining a lot of acceptance. And so it's becoming a commonplace strategy for not only river restoration, but reducing flooding. So with that, I'll run through the specifics at each of these. So Mechanics Pond Dam, a preliminary dam removal study was conducted last year, back in 2024. So this scenario involves removal of the physical dam, the concrete dam, and then a portion of that earthen berm dike. And so you can see in this figure, the right laser pointer, the green area that is currently impounded becomes available for flood storage. So it's almost like you've had this bathtub that was full of water, and now you carefully, released enough water over time that now that bathtub is empty, and dam removal makes that space available again to fill up when a huge flood is coming downstream. So you're creating a new flood storage space. You're making the river more resilient when a large storm comes by creating more flood capacity.
Jonas, can you talk a little bit more about that green area? That would, over time, again, as this eventually would become a wetland area, correct?
Correct, Gary.
So there's habitat there, wetland.
Yes, and we have some really good pictures that we'll show in a bit, showing what that restoration process looks like. But yes, this would become, it doesn't just stay, the bottom of a river that looks muddy. It very quickly fills up with vegetation, becomes a lush wetland area. And that's what we've seen in the dam removals that have occurred across the state, is with very little human intervention. They just revegetate from the dormant seed bank, the seeds that used to be in that wetland area that were flooded in the first place. Question?
What will happen to the embankments that are now lowered? How much can the soil drift away and the embankments come away?
We would expect some of that to happen naturally as part of the process. So within that green area, absolutely there would be sediment transport, and that would be part of the river essentially carving out a channel that it probably used to have, and the sediment that has become trapped over time would be allowed to flow downstream. So we would expect that.
Is there any way of reinforcing that embankment? Because where I live, it's very close.
Oh, I understand your question. Did you want to?
You mean the steep slope on the edge of the impoundment currently?
Right, near
Is your
Berwick and
question.
Mechanic Street itself.
Okay, sorry, I misunderstood your question at first. We would definitely, or if this project went forward, it would be really important to ensure that no sort of slope failure would occur. That would absolutely be part of any sort of dam removal study and project that occurs. Most of the transport I was referring to is within the currently impounded area, not up the slopes past the impoundment. But if reinforcement is needed, then absolutely that would be something that the project should and would include.
Yeah. This map here, is there one where it overlays the residential areas so we can get an idea of the impacted areas other than just looking at them?
So right now, the green is all water. So there's no residential area specifically impacted within what you're showing here. But yes, the north is this way, so it is a little confusing, sorry for the kind of the white background. But this is a residential area throughout here. This is Larson Woodlot with trails. This is Sterling Lofts here. And then there's houses, as was pointed out, kind of on the embankments.
In Mechanic Street's to the right, correct?
Yes.
Michelle?
Yes. It's a little faded out on here. I apologize for that. And this is where Simmons Pond is up here. This is the Bungay that comes down. This is 10 Mile coming from Farmers Pond. So that kind of gives you the sense.
I
So
guess
we'll be lowering that water surface out.
I guess it would be easier to picture if it had like landmarks, I guess, instead of green in the river. Like,
Yes.
But that
Agreed.
answers your question, that what you see, that little projection into that green area, that's above that. So so lower is lower, that subdivision is higher.
okay.
So people are all living up higher. It drops down to the pond currently. Then it would drop even further with a floodplain and the channel below. So all of that would be lower. But I agree with you. Yes, we should have an area on the back of that, which you'll see magically with the next one. What we did is we took the preliminary design that was done before on separate projects, and showed it here. So that's why they look different.
So here's from the preliminary study for Farmers Pond Dam that we performed just this spring. And so this involved, our restoration scenario involved the removal of the main portion of the dam as well as the auxiliary spillway to the side. And so again, you'll see higher up are these residential areas. This green area right now, that entire area is ponded. And so removal of the dam would reduce that ponded area to just this blue, ribbon of the river. And so all of this green area, some of which is already kind of vegetated looking, because water levels are fairly low above the sediment, a lot of that would just revegetate and become wetland area. And the residential areas would just remain higher up and would be farther away from the water, although they're relatively high up right now. And so I did want to run through this sort of case study. So the Keyes Parker dam removal along Sucker Brook and Pepperell was a dam removal that Horsley Witten was involved with between 2019 and 2021. And in 2021, over, I would say, a one-day period, it was really a 2-hour period, the dam was safely and quickly removed, and the restoration process followed suit. So here are some pictures. Here was that dam. We're looking from downstream to upstream, so we're just beneath this 3 or 4 foot tall, mostly rock with a concrete base dam. And then as removal started, it was opened up towards the right side of this picture. You can already see some bank popping out, and you can almost see a curve going on. So this was within, less than an hour. And then that same day, with the dam removed, you can see the sinuous river reemerging. Same day, it's already moving some sediment and becoming a narrower channel. And then within 2 weeks of removal, it has carved out some sediment transport has occurred, and you see banks reemerging, floodplain that would be filled up during a major flood event. And over time, that keeps deepening, 3 weeks, 6 weeks, to 6 months. And you can see the bottom of the river too has changed too. That looks much more sandy, less like silty deposits. So this could have been the natural river bottom reemerging. And then you start to see, this is only 7 months, you can start to see some green little sprouts popping up.
And I just want to point out that at 6 months, it was just April, so the very beginning of the growing season. You would have seen green earlier, but it was open winter. So it didn't take 6 months for the vegetation to reemerge. It's just that was the time period.
Right, thanks, Michelle. This removal happened the last week of October, so there wasn't much opportunity for it to regrow. So the growing season, it's been about 1 month into the growing season, green sprouting up, and then within 1 more month, you really see this nice bed of vegetation.
I noticed no one removed that tree though, that's in every picture.
Yeah, so that's some natural habitat, and it made a very good photo reference point too. 11 months, incredibly lush, and then the most recent picture we have is from 3 years later. You would never know that a dam had been here in the first place, and this is in people's backyards up these hills. Is just this, preserve, and there are trails on the left side. You can't see it, but this whole area can still be accessed, and you can look up at this, and it's now being used to count trout and understand the restoration process and how it's been impacting the species.
So clearly Pepperell is different than Attleboro, but this process would be similar as what we would see with your dams. I mean, you still have the trees and vegetation kind of around the edges, And so we thought that this would help you kind of envision, yes, you're not gonna have immediately trout back when they get up there. I mean, it's a different location, but this type of work is happening across the state, and it regrows almost immediately. It is really quite something.
All right, so we can talk through the results a little bit. I want to give people a chance in case you had any questions about the dams that we looked at, or if maybe we took care of questions as we're going. Okay, we're again focused on the County Street Bridge as sort of our comparison point. So right now, the 1% flood event overtops the County Street Bridge. It just goes over the top of it. Here on the profile.
This indicates the bridge material itself, so the road would be here. Just, I know it's weird to look at a model result, but this is that profile. That is the top of the bridge, and that is where the estimated water level is.
Right.
Just to clarify that.
So, some numbers related to that. So that water surface, 111.37, the bottom of that deck, so the bottom part of the bridge, if you were, going under the bridge, it'd be your ceiling or your roof. That's 110.1 feet. If the bridge were being built, from scratch, designed from scratch, often you would design with a goal of having 1 foot of space below that bottom of the deck, so that even during the 1% event, there'd be a foot of air that you would have as like a safety factor that wouldn't be flooding the bridge. So that was one of the guidance points that we kept in mind as we evaluated what scenarios would be, the most successful. How could we achieve the design that you would do if you were making County Street Bridge from scratch today? I'll break down this table a little bit, just so it's not just a box of numbers. So existing conditions, we just talked through some of these elevations. We evaluated dredging, as we discussed, resulted in about a 1/4 foot decrease in the water elevation, not enough to avoid overtopping or hitting the sides of the County Street Bridge. And we looked at that one just as its own scenario, because that would be, it wouldn't necessarily involve other projects. You could just do dredging today without these other restoration scenarios, but it wouldn't necessarily fix the problem. It wouldn't, prevent flooding at County Street. So then we looked at widening Railroad Bridge and the Olive Street Bridge. And we looked at those together because we saw that had the maximum benefit when both of those scenarios occurred at the same time. And so that resulted in a larger decrease in water levels than dredging alone, and would be expected to result in some of the same sediment transport that dredging would also accomplish. So the same removal of sediment, while also removing this root cause of the sedimentation, the root source of the problem. But again, that was not quite enough to achieve those goals at County Street. Then we added on the County Street Bridge and floodplain restoration scenario. So combining all 3 of these bridges, we saw a maximum benefit for decreasing flood elevations at County Street. But we took it one step further because while this addresses the, County Street specific issues, it doesn't alleviate this looming risk and hazard that dam failure would present. So we wanted to include dam removal as a scenario, and taken together with removing Mechanics Pond, removing Farmers Pond Dam, and widening these bridges, and building the projects from downstream to upstream to get maximum benefit from these, removing the constrictions, and then coming from above and removing the risk from dam failure, is what we found to be our recommended top priority projects. pass it to Nick unless we want to. Yeah.
For with the bridges or the structures, I guess inspected kind of recently, are they in good shape, especially if being like, if they were overtopped kind of recently, and then widening the bridges, that means like completely replacing, right?
Right. So widening a bridge would involve probably a full replacement. I don't know in terms of the recency that any of the bridge inspections occurred. I'll definitely note that widening could occur opportunistically. So as the bridges age and a replacement is planned, that would be probably your ideal time to widen them, or prioritize if the railroad bridge and the Olive Street bridge have the same priority level, but Olive Street has a sooner timeline for when a replacement would happen. That's an opportunistic time to also say, let's get in there and make sure we have the new design be as wide as it needs to be.
And I'll take that opportunity to say that all of those bridges we looked at were constrictions. And we are calling out the most impactful scenarios to work together. But if you're replacing Mechanic Street Bridge or the road work that's being done there, it should absolutely be widened at the same time if possible, because each step incrementally can help reverse what we've done over the past more than 100 years. So they are constrictions. We were just focused kind of on those top impactful ones. Certainly that pedestrian bridge at Sterling Lofts, it floods. That's the other spot that we saw that gets overtopped at the event that we were looking at with our model. But removing that didn't make a big difference for the County Street area, but it would definitely make a difference for the local, for Sterling Lofts and for that immediate area. So I just wanted to point out that they're all constrictions. We didn't find one that was the perfect size. So just keep that in mind as the city's planning for the future, looking down the road. They should be widened when you get a chance.
Speaking of the future, when you're coming up with your plan, mitigation plans, they are taking into account the 100-year or the 1% rule. What is being done? Clearly, you even stated it, and I completely agree that frequency and intensity they're increasing. How are you accommodating that in this plan? And is there a mechanism who changes it from 1% to 2% or 10%?
Federal government, that's FEMA.
Okay,
Well,
so
we looked at, for this study, and I wasn't sure if it was the 10-year return storm, which was causing the flooding that you're seeing. We wanted to address the flooding that you've been seeing recently. And from our calculations and comparing rainfall and intensity and flows and all of that, it matched with what FEMA was calling the 1% storm. So that was our focus for this, trying to address the flooding that you see now. It will only help with the flooding that we're going to see in the future. But yes, more is needed, and it is hard to kind of estimate and work on that. But we were approximating the storm events that's caused the recent flooding, so that was the focus. I wasn't sure if we were going to have to look at a much smaller storm to deal with. So if that kind of helps, there are going to be bigger storms in the future, more intense storms, and every little bit is going to help.
So as a follow-up then, widening something is futile because you're widening it based on 1%. Clearly, it's not going to be 1% anymore. So widening it is, we're just going to have to, some future resident is going to have to deal with how do you make it 52 feet rather than 48.
Just to kind of comment on that, we are looking at a width based on reference rivers and other places that are more natural and given the watershed draining to it. So the width that we are looking at is a little bit separate from the storm flood event that we're modeling. So we did model the 1%, but the width that we are recommending is based on the river and its watershed, if that helps.
It's
It doesn't
natural,
mean that
it's
gonna be
natural width, correct?
correct.
From 100
Correct.
years ago, potentially, right.
So we look downstream at some of the more natural or less altered sections along the 10 Mile River, and that gives us a sense of like how wide the river normally fills up before it spills into those floodplains. So that's the width, just based on the natural bank full width, before it would even fill into the floodplain.
So trying to be conservative while being realistic when replacing the bridge. But we are trying to be conservative and look at that natural width versus just picking the specific width that's going to pass the 1% storm.
And that's really consistent with statewide and, you know, regional design guidelines for how large you could reasonably make a bridge or any sort of structure that crosses a river, while also, you know, you meet your goals of flooding and maybe fish passage, while also being reasonable for, you know, what can you build as a bridge. You can't necessarily make 1,000-foot wide bridge to match 1,000-foot wide floodplain.
Sure. To be clear, my concern is the moving target.
Right.
Sure, and absolutely valid concern, Mike. Moving forward, I mean, as we, get to selection of choosing the scenario that we really want to pursue further, we're absolutely going to take latest climate data under consideration. I mean, not just looking at FEMA's 1% storm, but looking at the latest rainfall models. Just like we update our stormwater management ordinance. We updated that to use NOAA Atlas 14 because our consultants recommended that as the latest and greatest rainfall data. A lot of the state grants that we pursue nowadays, such as the Municipal Vulnerability Preparedness Grant, actually require us to use the state's climate resilience tool. Looking at, okay, what do you have for infrastructure that's in your project area? How critical is that? And then looking into the future of climate data to see just how impacted it could be by your storms, but then also by the project that you're presenting to them for grant funding. So moving forward, we're going to be looking at climate data, trying to accommodate that as best as we can, given all of the site characteristics and constrictions around it.
And again, unfortunately, there's not going to be a magic wand that we can wave and fix over 100 years of impacts to this river corridor and its floodplain. And so it's going to take time to reduce some of these impacts and get back to a more natural system. And this will be just the beginning and kind of looking at what the options are.
I'm a long-time member of Friends of the 10 Mile River Watershed, so I'm all for a free-flowing river. We have a counterpart over state lines in Rhode Island who have similar goals, and they did a study on the Pawtucket Country Club Dam for removal. But because of contaminated sediment behind that dam, which could pose a risk to human health, they got a hard no on that one. So, my question is, do you have any idea what is down in that sediment right now? Have any studies been done, or if not, when are we looking at those studies?
So some preliminary studies have been conducted at both Farmers Pond and Mechanics Pond dams. And so we do have some understanding of the initial sediment quality. And it seems from, I'll speak to the Farmers Pond dam because we conducted that study, the sediment downstream is just as, if not more contaminated than the sediment upstream. Part of that is that Mechanics Pond is immediately downstream of Farmers, and so that's sort of the receiving sediment. Massachusetts and Rhode Island do have pretty different procedures or histories with dam removal. I think it's more dam removal has occurred in Massachusetts than in Rhode Island so far. Yep. So Mass DEP is, I'll just say, has had more examples or more experience so far with dam removal, and it's entirely feasible that it would be permittable to remove those dams.
That's really good news.
Yeah, so Ben, just to expand on that further, so for the Mechanics Pond Dam, the consultant that we had involved looking at the preliminary design for removal of that, they were absolutely looking at contamination there. They did do some settlement sampling to get the most updated as they could within the confines of the funding that we had for that project. They were given all the EPA data from the upstream Walton and Lonsbury Superfund site, because if anyone's familiar with that project, that does discharge, some of that plume got into Bliss Brook, which then comes downstream into 10 Mile and then subsequently into Mechanics. So we did have some previous mapping of where that sediment was located there. We got a little bit more updated mapping from the preliminary design of Mechanics Pond. Now, one of the things that was mentioned by the state, this was a grant funded by the Department of Ecological Restoration, is they were very concerned, as well as you are, about sediment transport. So in the preliminary design, they did give us some methods of how that could be mitigated, essentially putting in, almost riprap check dams into the bottom of the stream itself, just to try and capture some of that, knowing that some sediment would be transported, but then we're looking at different thresholds within the Massachusetts contingency plan to see, okay, what's an allowable threshold to transport downstream. Now, conclusion of that project, though, was that a lot more data needs to be collected, both upstream and downstream, looking at the existing sediment levels, and then looking at, okay, if you take the dam out, in whatever way you do that, how much is going to be transported. So with all these scenarios, we need a lot more evaluation and design, but we're certainly not trying to transport any problems from upstream downstream.
Well, yeah, absolutely, absolutely. I was just curious if we're gonna hit a wall like a dam. And then my final part to this question, I see that, Mechanics Pond, Farmers Pond are being evaluated, which is great. What is the reason why Simmons Pond is not being evaluated for removal? I mean, doesn't it, if we have the momentum to remove these dams, shouldn't we just bang out all three of them?
So the reason why we've looked at Farmers and Mechanics right now is due to the high hazard status that they have. Those are much more of a significant threat to the damage of property and potentially lives if they were to fail during a flooding event. So that's why those two were chosen. 10 Mile River typically has a lot more volume of water coming through it as well. And then it's just available grants as they come through. So, we started with Mechanics at the first opportunity with how much water is being impounded by there, its proximity to downtown. And then the following year, we got Farmers. If that grant program for preliminary design is available again, we'll evaluate the dams that the city owns themselves and make a decision on what our next dam will be after that.
Yeah, it's all good stuff. Interesting fact I do want to share. The 10 Mile and the Blackstone rivers each have the same amount of dams, with the 10 Mile being half the length. So, all 4 dams coming out, definitely.
Yeah, and I do, there are, some of the private dams that people aren't aware. We have Dodgeville Pond Dam just downstream, and then after that we have the Evenville Pond Dam. When conversations of those dams do come up, I do ask if they are interested in removing the dams at any point. No interest currently.
Yeah, I can see some pushback happening.
Yeah. But, I'm always willing to have that conversation with people to see, how the city could maybe help in looking at different designs and options.
Be amazing if we could get a free flowing river through the city of Attleboro. That would be really
Certainly some significant ecological benefits for it, yes.
So, we're talking today about the implications of removing dams and what happens with contaminated soil going downstream. We did the same thing in the reverse for Dodgeville Pond back in 2017, 2018, over the course of 3 grant cycles to keep Dodgeville Dam. While the pendulum is swinging to the left to remove them, why would we keep Dodgeville Dam? So we made a cogent argument as to why to keep Dodgeville Dam. And in that scenario where, one phase of the grant, and this was all paid by Dam and Seawall grant program, about $2 million, a feasibility study, which we passed, then went to the design standard level, which we passed, and then we did a cofferdam. So there's a cofferdam temporarily. We actually have to get that dam on, that cofferdam on eventually to build the permanent dam. But my point about all this is you talked about contamination. As you excavate, there's turbidity and that goes all downstream. We did corings every 35 or 40 feet of that dam, and we found contamination. And part of the remediation before we could even build that cofferdam was get that all excavated. And that's very expensive because you can't just take that to any landfill. I think there was a place, Nick, was it up in New Hampshire or something?
Yes.
That we had to, and we actually got another extra grant, work with the state, to have that material excavated, inspected, properly put in trucks and taken up to New Hampshire before we even put the cofferdam in. So my point is that while, of course, we're looking at potential contaminated soils not to go downstream, when you were taking out a dam, we did the same analysis when we kept the dam. So they keep our feet, well, not to say they have to keep our feet close enough, we do ourselves anyhow, but that's all very strictly permitted. So But anyway, I just wanted to add that even when we kept the dam and rebuilt it, we had to go through the similar steps to evaluate the soil conditions and how to best remediate that, so.
Yeah, I remember when that dam was repaired. I remember talking to Gary down there and everything.
Oh, Gary Demers?
Yeah.
Yeah,
So I
sure.
do appreciate the information. Yeah, I mean, sitting here and listening to this presentation, it's gonna be costly, but definitely, from my standpoint, these dams are gonna have to be dealt with at some point, sooner or later, so, you know.
And we're looking for that long-term increased resiliency, so trying to make the city able to, adjust to the changing climate and the larger and more intense storms. We're never gonna build our environment or the built environment that can withstand like the worst storm in the world, but we wanna be more resilient to the ones we're seeing more frequently. So we don't have these drastic impacts, and we can make Attleboro just a safer place to live and do business.
So to that point, one level of storm that we barely ever talk about is the 500-year storm.
Right?
That's there, but we don't talk about that because, again, it's so improbable, but who knows what the trajectory we're going through. But there's that level of storm that don't design by, you have to design by the 100-year storm and the frequency of that storm.
Due to the ever-changing regulatory environment, I find that getting funds to remove dams might be hard for the foreseeable future. What a small victory in the sense of that Balfour Park, that seems like that slope, that seems like a small but impactful victory that doesn't need near as much logistics and studies to accomplish, but it serves as flood mitigation as well. Do you think implementing smaller steps towards a larger goal might be better than removing this dam and removing that dam, which are obviously very important, but much longer term, working on a sprint as opposed to the marathon?
I think that you would be surprised. It's going to be a little difficult to deal with Balfour. There's some contamination issues there. So that will take actually a little bit longer than you think, but I hear what you're saying about small actions that we can move forward with kind of in the near term, and I definitely agree with that. But also on the dam removal front, I think you're referring to maybe reduced federal funds for projects like that, but in Massachusetts, there is still strong funding for that type of work, both for the design and moving forward. So, and we've been in talks with that department and whatnot. So don't lose hope on that front. But yes, making incremental progress, whether it's just doing more evaluations and design and permitting, every little bit is going to help.
Plus, it's a combination of all these.
Yes.
It's not any one Band-Aid to, remedy the entire thing.
Any other questions for the moment? All right. So talking about the next steps, next phases of this project. So this grant project is due to wrap up by the end of September. And then there will be a comprehensive flood mitigation resilience plan. That'll be a written plan that's presented to us. But to get to that plan, the next step is to develop a benefit cost analysis of some of the proposed mitigation measures and scenarios that we discussed today. So looking at, okay, what is it going to cost for further design plans and evaluation, permitting, construction, and then really looking at the benefits of those actions. So you saw just a small snapshot of some of the benefits, looking at how much elevation we would decrease the water if we did some of those. But now it's time to, try and quantify that. What's that going to take? So our elected officials can really get a better idea of what's something that's truly worth pursuing based on the analysis that Horsley Witten Group will provide us. Once we do have that full mitigation and resilience plan provided to the planning department, we will be presenting that to the mayor and city council, really giving them a good comprehensive summary of all of the potential scenarios, what that's looking like for permitting timelines and further design, and then if we can, as best as we can, trying to give a potential estimated construction timeline. But something to really keep in mind is that, as we've been saying already, a lot of these are long-term goals and actions. So unfortunately, none of these are going to be able to be done by, say, next year or even the year after. There's a lot more work to go through to get these to the next step. But in addition to, the goals of this project and some of these scenarios, we are working on a smaller scale with a couple of other projects. Most notably, around the downtown area, we are working on our green stormwater infrastructure project. So trying to look at our existing stormwater system to see where we can improve that, not only from a flooding standpoint, but from a water quality standpoint. So trying to take the water out of those pipes and infiltrate them closer to where it's falling to the ground, trying to reduce the amount of volume of water that is getting into the 10 Mile River during any of these storm events. So we are pursuing those in the short term. That project will be wrapping up this year as well. So we'll have that feasibility plan and report that'll also be presented to the mayor and the city council. And again, we will be pursuing further grant funding for the implementation of that. If you haven't already, please use the sign-in sheet in the back. We are just trying to make sure we can get a good, accurate tab for everyone that is appearing at these public meetings. There's also comment cards, so if you have any written comments that you weren't able to say during the course of the presentation, please fill those out and put them in the basket back there. And of course, if you have any comments in the future, please reach out to myself, Director of Planning and Development, Gary Arasian. Always happy to talk more about this project. If you have other ideas or areas in the city that you think absolutely need to be addressed, please talk to us. We know this is far from the only area that has flooding. We know South Attleboro has plenty of other areas that have flooding that we do want to address as well. So we are looking at all available grant funds so we can make sure that, it's not just the downtown that needs flood resilience, it's the entire city. And then with that, is there any other questions or feedback?
You're putting, well, from what you just said, you want to put something in so the water doesn't go into the 10 Mile River? So does that water have to be treated?
So the way we're looking at it with green stormwater infrastructure is essentially treating it naturally. What do I mean by treating it naturally? Creating shallow basins filled with the appropriate native vegetation so that, just like a rain garden, essentially. There's other options such as tree box filters that we can do where it almost looks like your standard storm drain cut out into the side of your roadway and your sidewalk, but there's a tree coming out of it. That helps take some of the phosphorus out of the water, helps remove total suspended solids, and it's going to infiltrate as much as it can before it gets rerouted back into the stormwater system.
So would you have to create a collection place for these pipes to go?
Yeah, so we would try, the goal of the project is to work within the existing city's right-of-way and on city property. So some of the most feasible areas that we've seen so far in the preliminary report would be looking at areas along County Street and Capron Park. We have all that available grass area that's not necessarily, not 100% of the grass is used. So right now, the vast majority of our infrastructure, stormwater infrastructure in County Street is just piped straight down to the 10 Mile River. So we're evaluating, okay, where can we find a low point in Capron Park that we can now discharge this into and just let it infiltrate into the ground naturally, just to try and reduce some of that volume going into the 10 Mile River.
So I think what you're asking is about that water being dirty and polluted,
Correct.
right? And so with stormwater practices, what you would do first is you have something that's called a pre-treatment, where you can capture the sediment, the sands, and the trash that's washed off the road. And that's in a place that's easily maintained. It can be scooped out and cleaned by DPW. And then the water will flow into the natural system that he was describing, and soaking down through the soil helps remove additional pollutants, and the plants take up nutrients and that sort of thing. These are not pollutants at a level that would cause, we're not talking metals, heavy metals, and at least not to the extent that you might find in the sediment and mechanics pond at that level. These stormwater practices have been tested and used for a couple decades now, so these are not some brand new way to send contamination to places as it isn't today. They remove those pollutants through the natural processes.
So it would be safe for like kids playing in Cape
Correct.
Park.
Correct, yep.
There's one point Roger Williams Park in Rhode Island has a lot of informational signage on a lot of their BMPs that they have in place. So if you're ever out there walking around, it'll explain what's going on and what it filters out, and they're really nice.
It's like an amusement park for stormwater.
Any other questions? All right, well, that concludes today's public meeting. Thank you all for coming.
Thank you.
Yeah.